Okay, so you've probably got a salt shaker in your kitchen, right? Ever really looked at it and wondered what's going on in there? I mean, it seems so basic, so boring. But here's the thing. The story of how that simple table salt gets made is, well, it's absolutely wild. It's a story about two super dangerous elements, a crazy chemical swap, and one of the strongest forces in all of nature. So yeah, let's dive into the surprising story of salt.
All right, to really get this story, we've got to meet the parents. And let's just say they're a little bit intense.
First up is sodium. Now, we're not talking about the sodium in your chips. No. This is pure elemental sodium. It's this soft, silvery metal that you could, get this, literally cut with a butter knife. But don't let that fool you for a second. If you drop a tiny piece of this stuff in water, it doesn't just fizz. It goes boom. It's unbelievably unstable, and it is just desperate to get rid of one of its electrons.
And its partner in crime? That's chlorine. In its pure state, it's this creepy yellow-green gas. It's super corrosive, and yeah, it's incredibly poisonous. In fact, it was used as a chemical weapon, so not good stuff. And just like sodium, chlorine is totally unstable, but for the complete opposite reason. It's desperate to steal an electron from someone.
So, let's recap. We've got an explosive metal on one side and a poisonous gas on the other. What in the world do you think happens when you let these two meet? I mean, you'd expect a total disaster, right? Something even worse. But what actually happens? Well, it's kind of like a chemical magic trick. A transformation that just makes no sense at first.
They make this. Sodium chloride. The plain old table salt you put on your fries. Seriously, the explosive part? Gone. The poisonous gas part? Totally gone. They have completely changed into something not just safe, but something that's essential for us to live. Yeah, I mean it. Your body is using these right now to fire your nerves and move your muscles. So the big question is, how is this even possible? How does this incredible alchemy work?
Well, the secret behind this whole amazing transformation, it all boils down to one single crucial event. A simple trade that completely changes who these atoms are. It's all about the electrons.
See, when an atom either gains or loses an electron, it stops being neutral. It picks up an electrical charge, and we call this new charged atom an ion. And this little guy, the ion, is the absolute star of our show.
Okay, so there are two flavors of ions. When our superreactive sodium atom gives away that negative electron, it suddenly has more positive protons than negative electrons. So it ends up with a positive charge. We call that a cation. And on the flip side, when that chlorine atom snags the electron, it gets an extra negative charge. We call that one an anion.
But why? Why bother with all this swapping? What's the endgame here? It all comes down to one word: stability. You know, atoms kind of want to be like the cool kids on the periodic table, the noble gases like neon or argon. They're super stable because they have a full outer shell of electrons. So by losing one electron, sodium gets that perfect stable setup. And by gaining one, chlorine gets the exact same thing. It is the perfect chemical win-win. And here's what's so cool about this. It's not just random chaos. We can actually predict which way an atom is going to go. Just by following a few simple steps and using the periodic table as our map, we can figure out if an atom is going to be a loser or a gainer of electrons to get that stable structure. It's basically a cheat sheet for chemistry's most important dance.
So, let's check in. Sodium is now a positive ion because it lost an electron. Chlorine is a negative ion because it gained one. And what happens next? Well, you know the saying, opposites attract.
That positive charge on the sodium and that negative charge on the chloride create this super powerful force that yanks them together. It's called an ionic bond. And it's not like they're holding hands. It's more like an invisible, crazy strong magnetic force pulling them toward each other.
And here's a really important rule. Everything has to be balanced. The universe just doesn't like things to be left with an overall charge. So for every +1 charge from a sodium ion, you need a -1 charge from a chloride ion to cancel it out. The whole thing, the final compound, has to add up to 0. Perfectly neutral. But this powerful attraction doesn't just stop with one sodium and one chlorine. Oh no, it builds something way bigger, way stronger, and much more organized. It builds a crystal fortress. Okay, so here's something a lot of people get wrong. We talk about a molecule of water all the time, right? H2O. But you can't really say there's a molecule of salt. And the reason why is pretty fascinating. It's because that attraction we just talked about doesn't stop with just one pair.
That force, that attraction, it shoots out in every single direction.
So one positive sodium ion isn't just attracted to one negative chloride ion. Nope, it's attracted to all the negative ions surrounding it. Up, down, left, right, front, back. And this creates this amazing, perfectly repeating 3D pattern we call a crystal lattice. That's literally why a salt crystal has that perfect shape you can see.
So, just how strong is this crystal fortress? Well, get this. To take about 58 grams of salt, that's a few tablespoons, and rip it apart into individual ions, you'd need 769 kilojoules of energy. That is a ton of energy. It just goes to show you how ridiculously strong these ionic bonds really are.
Okay, so this crazy strength at the teeny tiny atomic level, that's what gives salt the properties we can actually see and feel in the real world.
Because all those ions are locked so tight in that grid, these ionic compounds are really rigid, but also brittle. That's why if you hit a salt crystal, it shatters instead of bending. That super strong bond also means you need a crazy amount of heat to melt it. That's why salt has such a high melting point. And since those charged ions can't move, well, solid salt is actually a terrible conductor of electricity.
But wait, here's the final plot twist. If you do manage to melt that salt, or you just dissolve it in water, you break up that rigid fortress. All those ions are suddenly free to float around. And now that you have charged particles that can actually move, that saltwater solution becomes a fantastic conductor of electricity. The fortress walls have come down, and the ions are free.
So think about that. We started with an explosive metal and a toxic gas. And all it took was one tiny electron swapping places to create the stable, life-sustaining crystal sitting in your salt shaker. It really makes you wonder, doesn't it? What other amazing transformations are just hiding in plain sight in all the elements around us, just waiting for the right chemical connection to happen?